right, today we're going to be looking at algebraic simplification and formula rearrangement. So you might notice you have tons of examples on your guided notes there. I'm going to be looking at the ones that have this cute little star guy by them, okay? So just so you can follow along, it skips around a little bit. It goes in chronological order, but we won't go over all of them. Okay, so just a review of expansion. I know we've already done this and whatever, but just so we're all on the same page. Remember, when you square a binomial like this, we have to multiply it by itself. So we will be foiling it by itself. That's what it means to square something. So we'll FOIL, we'll multiply x times x is x squared plus 3x plus 3x plus 9. Okay, and that's still in brackets. And then we'll multiply that by the 2. We've still got the plus 1 in front, so 1. And then these combine to 6x, right? So we can multiply 2 times each of those terms, so 2x squared plus 12x plus 18. And then 1 plus 18 gives us 19. So 2x squared plus 12x plus 18. Okay. Yeah, so I think the rest is very straightforward. Yeah, just realize, again, anytime we multiply a binomial by a binomial, we do have to FOIL. So these, and these. Something like this, you'll notice that if you have plus 2 minus 2, your middle terms are going to cancel, but you can always FOIL and see that happen. Okay, so you're welcome to try those. I'm sure this is a review for you. Okay, so making y the subject of. So this is formula rearrangement. So we're solving for y. So we just want to get y alone. Very straightforward, 10 minus 2x. And then we just divide both sides by 5. Okay, so y is equal to 10 minus 2x over 5. If you want to separate that into two fractions, you can say, okay, this is 10 over 5 minus 2/5 x, right? And then 10 over 5 is 2. So 2 minus 2/5 x. So for example, if you wanted to graph this and you wanted it in the form y equals mx plus c, now you can see what the slope and y-intercept is, okay? Okay, here we're making x the subject, so we're just going to minus p, very straightforward. So minus p from both sides. X the subject here, so a minus 2 first, so tx equals s minus 2, and we'll divide by t. So again, super straightforward. And you can have this as your final answer, x is equal to that, or like we did in this example, you can separate it into two fractions. Okay, y, we can just simply add y to the other side. So mx, and then minus c. So we're adding y, we're minusing c. Mx minus c is equal to y. Here we're solving for y, so we're going to minus n. So we have negative k, y equals 5 minus n. We can divide by negative k. Okay, so we get y is equal to 5 minus n over negative k. If you're wanting to cancel the negatives, you have to negate every single term. So that would mean making everything the opposite. So we'll make 5 the opposite. So right now 5 is positive, so we'd make it a negative 5. We'd make a plus n and a positive k. Okay, so these are equal. Okay, but it only works if you negate every single term. Okay, z, we're solving for z here. We have a times z, right? That's what az means. So we're going to divide both sides by a, or essentially multiply by 1 over a. So z is going to be equal to b over, and then we always write our variables in alphabetical order. So b over ac. If we want to solve for z here, we're dividing by z right now, so we want to multiply both sides by z. So a is going to equal dz. Okay, here we can cross multiply. So anytime you have two fractions with an equal sign in between, we can cross multiply. Z times z is z squared, and 2 times a is 2a. We want to get just z though, not z squared. So to undo this square, we can take the square root of both sides. So z is going to be equal to the square root of 2a. Okay, we're getting a alone here, so we're going to divide by m. So a will be equal to f over m. H is what we want to get alone in this next one. So we're dividing by 2, so we're going to multiply by 2. So we have 2a equals bh. We want h alone, so we'll divide by b. So h is equal to 2a over b. Okay, so here they're getting a little bit more complex. If those last ones were too fast, hopefully you were able to pause the video. Yeah, these will get a little more challenging. So we want to make r the subject. We're going to divide both sides by pi, which is just a number. So a over pi is equal to r squared. And we want to get r alone, so we want to get rid of the square, which means we'll have to take the square root of both sides. So r will equal the square root of a over pi, and all of that is underneath the square root. If you want to, you can even say it's equal to the square root of a over the square root of pi. Okay, those are equal. You don't have to do that step though. This is just fine. Okay, so either way. Okay, here we want to solve for r again. So we have v is equal to 4/3 pi r cubed. Okay, solving for r. If we divide by the fraction 4/3, it's the same as multiplying both sides by the reciprocal. Okay, so dividing by 4/3 is the same as multiplying by 3/4. So to move it to the other side, we're going to multiply by the reciprocal. So we're going to multiply this side by the reciprocal. So we have 3/4 v is equal to pi r cubed. To move pi over, we can divide by pi. So when we divide by pi, we're really multiplying by 1 over pi. Okay, so now we have 3v in the numerator, and we have 4 pi in the denominator, is equal to r cubed. To undo a cube, we're going to do the cube root of both sides. Okay, so then we get r is equal to the cube root of 3v over 4 pi. Okay, and then again, you can write this as the cube root of 3v over the cube root of 4 pi, if you like. But this answer is just great too. So either way. Okay, so here we're getting a by itself in the first one. I guess in the first three. So we'll want to multiply our n over. And again, we write our variables in alphabetical order. So we have dn is equal to the square root of a. And then to undo the square root, we'll have to square both sides. So when we square dn, we're going to square d, and we're going to square n. And that's our final solution. Then for c, so we want to get a alone. We always have to start with the outermost thing. So right here, we've got a square root on the outside of this side. So to undo that square root so we can access the a, we're going to have to square both sides right away. And that's going to undo the square root. So we'll have c squared is equal to a squared minus b squared. We'll add b squared to the other side. So we've got b squared plus c squared equals a squared. And then, yeah, we just want a, so we'll have to square root both sides because we don't want a squared, we want just a. Yeah. So we'll have the square root of b squared plus c squared is equal to a. Okay, so that's that one. Okay, next one, we want to get A alone here. So P equals 2 times A plus B. We can divide by both sides, divide both sides by 2 right away because it's on the outside and we want to be able to access our A. So P over 2 is going to be equal to A plus B, and then we can just minus B to the other side. So P over 2 minus B is equal to A. And the last one. So here what did we have? We have I equals E over R plus R. Okay, so notice we want to solve for the little r, right? Okay, so it's in the denominator right now. That doesn't do us any good. We need it in the numerator in order to solve for it. So we're going to multiply this quantity over to the other side. So we're essentially multiplying both sides by r plus r. Okay, and what that's going to do is it's going to cancel the one on this side, and we're just going to move it over to the other side. Okay, so now we've got r plus r times I is equal to E. So we can divide our I to the other side. Oops, that's pi, not I. Okay, and then we're left with r plus r equals E over I. And then we can just subtract the big R. Because right now we're adding it, right? So we're going to subtract it to the other side. So r equals E over I minus the big R. Okay, again, a little more complex. Notice we've got two x's, right? So we're going to have to get our x's on one side, and anything that doesn't have an x, we're going to move it to the other side. So we can subtract bx from both sides. So we have 3x minus bx plus a equals c. E doesn't have an x, so we're going to move that to the other side. So 3x minus bx equals c minus a. Okay, and then similar to equating parts of surds, notice we've got an x and an x. So we're going to factor out that x. Okay, so we're going to have x times 3 minus b. That's what's left when we factor an x out of each of those, is equal to c minus a. And we want to do that because we're trying to solve for x. We want to be able to get x alone. So now this is multiplication, right? X times the quantity 3 minus b. So we're going to divide both sides by 3 minus b. So x is equal to c minus a over 3 minus b. Okay, similar situation. We want to get all our x's on one side. So 8x plus bx plus a is equal to 0. We can move the a to the other side. And we want to solve for x. We can factor x out now from this side. And then since this is multiplication, we can divide by a plus b, both sides. So x is equal to a negative a over 8 plus b. Okay, so last examples. We want to get x alone again. So notice it's in our denominator. So for sure we have to move that denominator into the numerator on the other side. But look, we've also got an x here. Okay, so to move this denominator, we'll have to multiply both sides by the quantity x plus 1. So it's going to cancel this. So we'll have y times x plus 1 is equal to x. Okay, because we have x's on both sides, and this x is trapped in those brackets, we're going to distribute the y. Okay, so we're going to have xy plus y right? 1 times y is equal to x. And what that does is it allows us to get rid of those brackets, and now we can move anything with x to the other side. Okay, so we have all our x's on the same side. So we can minus xy. So we have y is equal to x minus xy. We're still solving for x, so we're going to have to factor x out from here now. So y is equal to x. So if we factor an x out of x, we're just left with 1. And if we factor this x out here, we're left with minus y. Okay, and then we're going to divide both sides by 1 minus y. And so x is equal to y over 1 minus y. Okay, last one, similar situation. We've got an x in the denominator, which we for sure have to move to the other side. And we have an x in the numerator, so we'll have to distribute and rearrange. So to move x plus 2, that quantity, to the other side, we'll have to multiply both sides by x plus 2. So it's going to cancel this. And over here, we'll have y times x plus 2 on the left is equal to x minus 3. We'll distribute our y so we can move all our x's to one side. So we'll have xy plus 2y equals x minus 3. Anything that has an x, we can put on one side, whether the left or the right. I'm going to move them to the left. Okay, and anything without an x is going to go on the other side. So minus the 2y over there. Okay, so now we can factor out our x from the left side. So we have x times y minus 1, right? Because if we factor an x out of here, we're just left with a negative 1, is equal to a negative 3 minus 2y. Okay, we want to solve for x, so we'll divide both sides by y minus 1. Okay, this may be another example where you're thinking, gosh, there's a lot of negatives here. I don't really like the way that looks. If that's the case, again, you can negate every single term. So you're making every single term the opposite. So instead of a negative 3, we'll have a positive 3. Instead of a negative 2y, positive 2y. Negative y, and a positive 1. So this is also a possible solution. Okay, so you can have either x equals negative 3 minus 2y over positive y minus 1, or you can have positive 3, positive 2y, negative y, and positive 1. Either way. Okay, thanks a lot.